At this point, we're ready to start building our Quart counter application. So start the Docker client if you haven't already, and let's bring up just the database for now. Make sure you're on the counter application folder and type the following command. Docker will start downloading the Postgres image and start the database container in the background. Be patient, this might take a few minutes on the first run, but should be faster after that. We only need the database up while we write our code. We'll build and run the web container a bit later once the application is in place. We'll now add the database packages we will need. The first is SQLAlchemy with its Async IO Extra, which gives us SQLAlchemy 2.0's native asynchronous support. The second is asyncpg, the async driver that actually talks to Postgres. As we mentioned earlier, we'll be using SQLAlchemy's core module, not the full ORM, for our application. Add them with uv-add. The nosync flag just declares them in pyproject.toml, and they get installed when Docker builds the container. Now we'll go ahead and create our database driver file. So create a new file we'll call db.py. First, we import metadata and create a sync engine from SQLAlchemy. The create async engine function is the async counterpart to the regular engine. It's what lets us run queries without blocking the event loop. We'll also import the current app from Quart. Think of the current app as the currently running instance of the Quart application. We'll need it to read the settings that we've set for the database connection. We define an application-wide metadata object that will track all the models in our application, which will allow us to manage migrations when we start using Alembic. Then, in getEngine, we build the connection URL from the settings. Notice the PostgreSQL plus asyncpg prefix. That tells SQLAlchemy to use the asyncpg driver. We return an async engine with a small connection pool, which we'll reuse across requests. Save the file. Now let's go ahead and create our first and only blueprint of the application, the counter module. First, create the counter folder, and inside create the empty initp, to declare it a module. Then create the models.py file with the following contents. We'll begin by importing some modules from SQLAlchemy. The names might sound familiar. Table allows us to set up a table in the database. Column allows us to create the table columns, and integer, which is the only column type we use. We also import our metadata object, which will allow us to do introspection about the table schema when we use migrations. You need this object in any model you create. Then we define our counter table as a table consisting of two columns. The ID, which will be the primary key, and count, which will hold the current counter of the application. Notice we define the table name as counter and add the metadata object as part of the definition. Save the file. Now let's go ahead and build the views.py file, which will be our main controller and blueprint. We'll import blueprint to create the counter app blueprint, as well as the current app, which we'll need to get the database engine. We also import the select, insert, and update constructs from SQLAlchemy and our counter table from the model file. The only route this controller has is the root /, which we'll call the init function. We begin by grabbing our database engine from currentapp.dbc. Then we open a connection with async with engine.begin. Using begin gives us a transaction that automatically commits when the block ends successfully, so we don't have to issue manual commits. Inside the block, we run a select on the counter table and fetch all the rows. In this application, it will always be just one record. Notice the await keyword. The query execution is an asynchronous operation that yields to the event loop while it waits on the database. We then get to the main forking point of the script. If we don't get any rows back, it means it's the first time we're running the application. So we build an insert statement. setting the value of the count column to 1 and await it. Since this is the first time we run the application, we can safely say that the count variable is 1. Now, on the else branch, if we do get a result from the select query, we fetch the first row. We then add 1 to the value of its count column and store it in the local count variable. We then build an update statement that targets the row by its ID, sets the new count, and await it. Because we're inside the engine.begin_task block, the change is committed automatically when the block exits. Finally, we return the value of the count variable to the request as HTML content. As you can already notice, any database operation must be awaited, since they are I/O operations that can yield to the event loop. Save the file. Next, we'll create the application factory as we've done in the past in my Flask course. Call this file application.py. We begin by importing Quart and the getEngine function from the db file we created earlier. Next, we define the factory function as createApp with a config overrides parameter that will allow our tests to change the settings environment variables when running them. We then create an app instance of Quart and configure it from the settings.py file contents. After that, we update the app with any changes passed on the config overrides parameter. Then we import the counter app blueprint from the views.py file and register it. We now need a way for the application to set up a reusable database engine. For that, we'll use a couple of special decorators called before serving and after serving. These decorators set up functions to be executed the first time the application starts and right before it shuts down, which lets us create the engine once and keep it around for all requests. For the before serving function, we create the engine with getEngine and store it in a context variable called dbc that will be available anywhere you call the current app in any view or model. Finally, with the after serving function, we call the engine's dispose method, which cleanly closes the connection pool when the app shuts down. Save the file. We're almost done with the core application. We just need to create the bootstrap file that will spawn an instance of the application factory. We'll call this file manage.py. This is a simple file. We just need to import the createApp function and then execute it and store it in a variable called app. Save the file, and let's go ahead and start with the database migration configuration.